Hello everyone, welcome back to the tutorials on Ansys Workbench. So before getting into the harmonic analysis, we will see what you mean by dynamic analysis. So dynamic analysis refers to the study of structures or mechanical systems under time-dependent loads or forces. So here the loads or the forces will vary with respect to the time. So it may increase with respect to the time, or it may be decrease with respect to the time, but it will change with respect to the time. So it is unlike static analysis, means in the static analysis the force will not change with respect to the time. So the force remains constant with respect to the time. So the dynamic analysis focus on how system responds to time varying inputs such as vibrations, impacts and the oscillations. So this is what the dynamic analysis means. So next, harmonic analysis. So it is a type of dynamic analysis that studies the steady state response of a system subjected to a sinusoidal loads or forces. So it determines how a structure or mechanical systems behave under periodic forces at various frequencies. So in this harmonic analysis, we are going to study how a machine component or a structure will behave for different loading conditions at different frequency ranges. So that is what the harmonic analysis means. So let's get into the problem. So this is the problem: bar subjected to forcing function. So consider a cantilever beam of length 1 meter subjected to a load of 100 Newton at the free end. Conduct a harmonic force analysis by applying a cyclic load at the end of the beam. The frequency of the load will vary from 1 to 100 Hz, modulus of elasticity 200 GPa, Poisson ratio 0.3, density 7800 kg per meter cube. So this is the cantilever beam. At the end it is subjected to a load of 100 Newton. So let's get into the Ansys Workbench. So find the harmonic response in the analysis system. As in the given problem, they are specified the frequency of the load will vary from 1 to 100 Hz. So in this case we don't need to find the natural frequencies because they have specified the load varying from 1 to 100 Hz. So you can use these values directly. If these values are not given, then we need to do the model analysis first. We need to find the frequencies, natural frequencies to the display's maximum amplitude. That natural frequency will be used for the harmonic analysis. So in this case it is given. So harmonic response. So engineering data 7800. So double click here. So this is 7800. So change this to GP. Okay, fine. So close this. Next, geometry, right click, design modular geometry. Click on XY plane. So go for sketching, line, draw the line, dimensions 1 meter. Click on generate. So now cross section, rectangle cross section. So it is 0.01 meter and 0.01 meter. So click on generate. So now convert these sketches to lines. Select this line, click apply and then click generate. So now expand this, click on line body. So cross section has to be assigned rectangle 1 and then click on generate. So you can minimize this, double click on model. So we can directly go for mesh, right click, generate mesh. Next, click on harmonic response. Right click, insert, fixed support. So select this vertex, apply. Next, insert, force, select this vertex, apply. So change this vector to components real bar imaginary, because if you have a combined cyclic loads applied on the beam, so then you should think about the real magnitude of the forces and the imaginary magnitude of the forces. So in this case, the real magnitude of the force in the y direction, so it is -100. Next, select analysis settings. So here range minimum is given as 1 and range maximum is given as 100. So if you want to get the smooth curve, so you can go for 100 solution intervals. So for every frequency you will get a graph over there. Okay, so next click on solution, right click, insert. So deformation, you can have directional deformation. So directional deformation is y-axis. So next, insert. So frequency response for deformation. So select the geometry, select this, apply. So again orientation is y-axis. So click on here and click on solve. So you can see the directional deformation. So for the maximum frequency of 100 Hz, the deformation will be at 1.83 millimeter. So now we will see the frequency response. So this is the frequency response plotted, amplitude versus frequency, and you can see the maximum amplitude over here. So this amplitude you can check here. So this is around 7.93. So it will be 1.2 meters if it is in meters. So in this frequency you will get the maximum amplitude. So you will get the results for 100 frequencies, starting from 1 frequency 1 to 100 substeps. So these are the amplitudes. So this is the graph. So if you want to zoom this part, so you can zoom this like this. So if you want to zoom that part, you can zoom like this. So second amplitude will get at 51 Hertz, I think so. So again go for images. So you just save the results. So this is how to conduct the harmonic analysis on a cantilever beam. Thank you. See you in the next video.